Okay, and if you go above that, then you get total internal reflections there. Welcome to today's lesson. Today we're looking at total internal reflection. So before we can do that, we need to talk about what's going on here. So we have the light source. As you can see, this is my laser. Right, you can move it all the way 90 degrees, as you can see here. The dotted line is of course what we call the normal. All right, and what we have is we have air. You can change the medium. We will do that later. And here we have water. Now let's take a look here. You are allowed to select your protractor. I'll just place it here. Here we go. Now let's switch the laser on. Now here we go. So what we have? So we have this ray that's coming in, and this ray, if you look carefully, it is partially reflected. So some part of it is being reflected back. So this is what will normally happen. But the main part is most of the light, as you can see, wanted to in the water, and it is refracted, so it is bended away. It is bended towards the normal. That's what we expect to see when light goes from a less dense medium into a more dense medium. The refracted ray is bended towards the normal. Now, if we decrease the angle of incidence, so this is the angle of incidence. If we decrease it, if you look carefully, then we still get the reflected ray, okay? And then the reflected ray is exactly the same as the incident ray. So for now, just focus on in the one in the air. So if I reduce it, then the reflected ray angles also reduce. If I increase it, then it also increases as well. So this tells us something remarkable about the reflection law, or the law of reflection. Okay, so I've denoted it here, I've noted it down, so this way you can see angle of incidence and the angle of reflection. So if I increase it, if I increase the angle, then the angle of reflection increases. If I decrease the angle of incidence, then the angle of reflection also decreases. So this gives us a law here, which I'm going to write it down. Okay, so the angle of incidence, so law of reflection states that the angle of incidence is equal to the angle of reflection. So this is what is happening. So when you increase it, when you decrease it, this is what's happening. Okay, it is always equal to the other. All right, and the refracted ray, as you can see, we already know what happens there. Now what we're going to do is we're going to swap the medium. Rather than having light coming from air into water, we're going to have it from water to air, and we'll see what happened there. Okay, so first of all, in order to change this, I'm going to change from air to water, and then the bottom one I'm going to change from water to air, and this is what we have. Okay, as you can see, we still have the same thing, but rather in this case in water, we have the ray coming in the water, and then it is, when it leaves the water, it is refracted away from the normal, and some part of it is reflected inside of it at all. Now let's take a look. As you can see here, we can still move it. Now we have this ray, a refracted ray that is leaving it. What I will do is I will increase the angle of incidence, which is this here. I will increase it slowly and slowly and slowly, and see what happened to the refracted ray. Okay, and if you look carefully, the refracted ray is going towards 90 degrees. Let me go slowly, and then it disappears. So I'll just slowly go. So as you can see, it's very hard to make the refracted ray on 90 degrees. So I've got it very close. So this here, okay, at this here, when the refracted ray it is near 90 degrees or on 90 degrees, we call this angle here. So normally it is the incident angle, okay, but there's a name we give it. We call it the critical angles. Okay, so the critical angle is just the angle of incidence, okay, at which the angle of refraction is at 90 degrees, which is parallel to the border. Okay, so I'm going to draw a line here so that you can see what I mean. So this angle here, this here is the angle of incidence, which we know. Okay, now when the angle of incident is at a particular angle, and this gives us a 90 degrees for the angle of reflection. So angle of refraction. Okay, so at this angle here, so when you turn, you keep turning it, and then when the angle of incident is at a particular number, and that makes the angle of refraction 90 degrees, we call this angle here, now we call this angle of incident, but there's a name we give it, and we call it critical angle. Okay, the critical angle is the angle of incident at which the angle of refraction is 90 degrees. Because at this point something remarkable happened, and I will show you what happened. Now if I increase this critical angle, if I increase it, okay, I'll just increase it, as you can see the refraction rate is gone. All we have is this, we have this reflected ray inside the water. If I keep increasing it, then you see there's no more refraction. We just get reflection. And this here is what we call total internal reflection. Okay, so total internal reflection is when you have a complete reflection of ray of light within the medium itself. Okay, within the medium itself, and you only get total internal reflection. Okay, so you need two conditions need to be met in order for you to get total internal reflection. So the first one is light need to be going from a more dense medium to a less dense medium. So light need to go from a more dense medium to a less dense medium. Okay, more dense to less dense medium. So light need to do that. And second, the angle of incidence. So angle of incidence. Okay, angle of incidence. It has to be greater than the critical angle. Critical angle. Okay. All right. So in this case, if I were to find that critical angle, I need to reduce it so that I can see the refraction rate. Here we go. So I'll try to get it down here very close to 90 degrees, and it's very hard. I'll try my best, slowly and slowly. Here we go. So at this angle here, for water is, so the critical angle here is going to be, as you can see, it is at 90 degrees, and it is roughly around this number here, and this is around 30, 35, 40, 45, I'm gonna say around 49 degrees. So this is the critical angle. The critical angle is the angle at which the angle of incidence. Okay, so the critical angle is when the angle of refraction is at 90 degrees, and critical angle here is just the value for the angle of incidence. Okay, so angle of incidence, okay, at which the angle of refraction is at 90 degrees. So when you get this to 90 degrees, all you need to do is look at this angle here, and this is your critical angle. There it is. Okay, and then beyond this, so if you keep increasing the angle, then you will get total internal reflection. Here we go. So total T internal I reflection, it is when you get a complete reflection of light within the medium. So as you can see, then the light is only stays in the medium itself. So if I increase it, if I increase the angle, then the light just stays in the medium, doesn't leave. And for that to happen, you need two conditions. The first condition is light need to move from a more dense medium, so the M here is more dense medium to a less dense medium. And second one is the angle of incidence here, this angle here needs to be greater than the critical angle. So therefore, for water, in order for you to get total internal reflection, the angle need to be greater than 49 degrees.